Picture this. A large air campaign is already underway. Fighters are airborne, tankers are cycling, satellites are overhead, data links are alive. From the outside it looks modern, fast jets, digital cockpits, networked weapons, everything you would expect from a contemporary air force. Now picture one more condition. This campaign does not last 10 minutes. It does not last an hour. It lasts all day. Then it continues into the next. Aircraft rotate, crews change, fuel flows, but the airspace itself does not reset. And somewhere above that airspace, something has to remain. Not strike, not dash in and out, not execute a single mission and leave. Remain. That requirement is easy to overlook, because most air power stories do not start there. They start with the aircraft that move, the aircraft that maneuver, the aircraft that deliver something and go home. But sustained air operations introduce a different pressure, not on speed, not on stealth, not even on firepower. They apply pressure on presence. As the hours pass, something subtle begins to happen. The faster aircraft are not the problem. They come and go exactly as designed. The sensors are not the problem either. They detect, classify, and transmit. The issue is continuity. Who is still there when the fourth rotation begins? Who maintains the same picture when the second shift takes over? Who holds the airspace together when nothing dramatic is happening, but everything still depends on coordination? This is where modern intuition starts to slip, because our instinct is to assume that continuity can be assembled from parts, that persistence can be achieved by enough rotation, that a network of advanced platforms should naturally replace a single specialized one. On paper, that assumption feels reasonable. In practice, the airspace begins to behave differently. Now imagine removing one element, not the fighters. They are still available, not the satellites. They are still overhead, not the data links. They are still connected. Remove the aircraft whose job is simply to stay. At first, nothing obvious breaks. There is no sudden collapse, no dramatic failure. What changes instead is tempo. Handovers take longer. Confirmations repeat. The same questions are asked twice. Small delays appear, then they stack. Pilots begin to rely more on onboard judgment. Controllers compensate with procedures. Everyone adapts, briefly. But adaptation has a cost. This is the part that rarely shows up in discussions about replacement. The conversation usually focuses on capability. Who can see farther? Who can process faster? Who can survive better? But the system does not fail at the peak. It strains at the seam, at the moments between sorties, between crews, between one picture and the next. That seam is not glamorous, it is not fast, it does not maneuver, it just holds. At this point, many people reach for a familiar answer. Just distribute the role. Let fighters share the sensing. Let drones fill the gaps. Let satellites provide coverage. Let software stitch it together. Again, this sounds correct. But notice what is being assumed. That presence is interchangeable. That staying can be approximated by enough movement. That continuity is simply a scheduling problem. Those assumptions work, right up until the system is stressed. And sustained air operations are nothing but stress applied over time. This is why, when people look at the aircraft orbiting quietly above a conflict zone, they often misunderstand its importance. It does not look decisive. It does not look modern in the way fast jets do. It does not appear to be doing much at all. And yet, when it is not there, everyone notices. Not immediately, not dramatically, but structurally. This is also why replacing that aircraft has proven harder than replacing fighters. Fighters are judged by what they can do in a window. This platform is judged by what happens when the window never closes. The difficulty is not technological, it is organizational. The airspace demands a reference point that does not blink, a role that is defined less by action and more by uninterrupted presence. And that role does not scale cleanly with performance upgrades elsewhere. At this stage, the discussion usually stalls, because the instinct is to ask the wrong question next. Not what can replace it, but why does the system behave this way at all? That question belongs to a different layer. For now, it is enough to recognize something simpler. In modern air operations, some aircraft matter not because they strike, but because everything else quietly aligns around them. And that is why one of the least dramatic aircraft in the sky has become one of the hardest to let go. As operations continue, something else becomes visible, not in the air, but in the workflow. The system begins to lean on assumptions that were never designed to carry weight for this long. Assumptions like, if one platform leaves, another can cover. If one crew rotates out, the picture will remain intact. If data keeps flowing, coherence will take care of itself. These assumptions hold during short windows. They hold during demonstrations. They even hold during limited engagements. They start to bend when time becomes the dominant factor. In sustained air operations, time is not neutral. Time accumulates friction. Every handoff introduces interpretation. Every rotation introduces delay. Every new node introduces alignment work. None of these issues are dramatic on their own. They only matter because they repeat, and repetition changes the system's behavior. This is where the idea of replacement quietly runs into trouble. Replacement assumes equivalence, that one thing can step into the role of another without changing the structure. But roles defined by staying are not interchangeable in the same way roles defined by doing are. You can replace a strike aircraft by matching range and payload. You can replace a sensor by matching coverage and resolution, but you cannot easily replace a reference point, because a reference point is not evaluated by output. It is evaluated by what remains stable around it. At this stage, people usually point to technology. Better sensors, smarter fusion, distributed networks. All of these help. But notice what they actually do. They increase capability, they increase redundancy, they increase options. They do not remove the need for a persistent anchor. In fact, the more complex the network becomes, the more the system depends on something that does not change state. This is the contradiction that makes the problem hard to talk about. Modern air forces are optimized for flexibility, for adaptation, for rapid reconfiguration, but sustained control of airspace punishes constant reconfiguration. It rewards sameness, predictability, continuity, not because those qualities are impressive, but because they reduce cognitive and organizational load over time. This is the point where one aircraft finally enters the picture, not as a hero, not as a solution, but as a structural placeholder that has been quietly performing this role for decades. The E-3 Sentry. For most observers, it looks like an artifact from another era, large, slow, obvious, which is exactly why it is often assumed to be replaceable. And yet, when air forces try to imagine removing it, they do not struggle with sensing, they do not struggle with computing, they struggle with keeping the same picture alive across time. This is not because the E-3 is uniquely advanced, it is because it occupies a position that modern systems still require, even if they are uncomfortable admitting it. A position defined less by what the aircraft can do, and more by what the rest of the system no longer has to worry about when it is there. At this point, the conversation usually becomes uneasy, because once you see the role clearly, you also see why replacing it is not a matter of swapping hardware. To remove it, you would need to redesign how airspace is managed over time, how authority is anchored, how continuity is enforced when nothing is actively happening. Those are not engineering questions alone, they are organizational ones, and organizational changes move slower than technology. This is why the E-3 persists, even as almost everything around it evolves. Not because it is untouchable, not because it is optimal, but because the system has not yet agreed on what should take its place without breaking something else. Notice what we still have not done. We have not defined the role formally. We have not named the pattern. We have not explained the mechanism. That is intentional, because once you name it, it becomes tempting to believe you have solved it. And this problem has not been solved yet. What matters for now is simpler. When people ask why the E-3 is harder to replace than fighters, they often assume the answer lies in technology. It does not. It lies in the uncomfortable realization that some roles in modern warfare exist not to act, but to make action coherent over time. And coherence, once lost, is far harder to restore than capability. By now, something should feel slightly off. Not confusing, just incomplete. You can see the aircraft, you can imagine the sensors, you can follow the data moving through the system. And yet, the question of replacement still does not settle. That is usually the moment people assume more explanation is needed, more detail, more diagrams, more technical depth. But the hesitation you feel here is not a lack of information, it is a signal. Because what has surfaced is not a capability gap, it is a structural dependency. And structural dependencies behave differently from hardware problems. They do not announce themselves when things fail spectacularly, they show up when everything works, but only if something quietly holds it together. This is why the difficulty of replacing the E-3 rarely becomes obvious during planning. On paper, replacements look convincing. Distributed sensors appear sufficient, advanced fighters promise awareness, networks suggest resilience. All of that works, as long as time stays short and transitions stay manageable. The moment operations stretch, the system begins asking a different question. Not what can see, not what can strike, but what keeps the same understanding alive when nothing decisive is happening. That question is uncomfortable. Because it does not point to a feature, it points to a function that exists between things. Between sorties, between crews, between decisions, and functions that live between things are notoriously hard to replace. You cannot buy them outright. You cannot upgrade them in isolation. You cannot remove them without shifting everything else. This is why discussions about replacing the E-3 often drift. They circle around technology, they circle around budgets, they circle around age. But they avoid the central tension. If you remove the aircraft, what exactly takes over its position? Not its radar, not its computers, its position in time. That is also why comparisons to fighters miss the point. Fighters are designed to enter and exit the system. Their value is concentrated in moments. The role we are circling here is valuable precisely because it does not concentrate. It smooths, it stabilizes, it reduces the cost of continuity, and that kind of value is invisible until it is gone. At this point, it would be tempting to name the pattern, to label the role, to explain why it exists, to argue what should replace it. That temptation is exactly where this discussion usually goes wrong. Because once the role is named, people assume it can be neatly reassigned. History suggests otherwise. For now, it is enough to sit with the unease, to recognize that some aircraft persist not because they outperform others, but because they quietly prevent the system from tearing itself apart over time. And to understand why, when air forces talk about replacing fighters, the conversation feels straightforward, but when they talk about replacing the E-3, it does not. That difference is not accidental, and it is not temporary. It is telling you something about how modern air power actually works.